Hi everyone, my name is Giovanna Proença and today I'm going to talk about AP Computer Science exam. So we're talking about some topics already. We're already talking about abstraction, binary system, and today we're going to talk about hexadecimal system. Let's see more. Hexadecimal system goes from 0 until 15, which contains 16 numbers, differently than binary that only contains 2. So how do we represent these 16 numbers? We normally use the number 0 until 9, and to represent the numbers 10 until 15, we use the letters A until F. Alright, so if we want to represent the 10, we're going to use A. If we want to represent 11, we use B, so on and so forth until we use the letter F to represent 15. How can we convert a hexadecimal number into a decimal? So here the idea is pretty much the same as what we did in binary, but the main difference is that in binary we were using the base 2, and in here we're going to use the base 16. So to understand how we're going to do this, let's see the next example. Let's suppose we want to convert the number 4e to decimal. The first step we're going to do is check how many characters we have in our hex number. In this case we have 2, 4 and e. Then we're going to create one table. The first row of the table we're going to do 16 power of a number, starting from 0 in the right until how many numbers we have minus 1, that is going to be in the right. So for example, in our case, we're going to have 16 power of 0 and 16 power of 1. So 16 power of 0 is 1 and 16 power of 1 is 16. The second row, we're going to convert the character into a real number. For example, from 0 to 9, it will be the number itself. But if it is a letter, we're going to convert the letters from A to F to 10 until 15. In our case, we're going to have 4 and 14. Finally, we're going to add the result of multiplying row 1 with row 2. In our case, the decimal number will be 4 times 16 plus 14 times 1. So in this case, our number will be 78. So far, we learned how to convert hexadecimal into a decimal. But how can we do the other way around? Let's see this other example. Let's suppose we want to convert the number 120 to hexadecimal. The first step we have to do is creating a flexible table with enough columns until the number in the row is just bigger than the number we are converting to. In our case, we would write the values 1, 16, and 256 that represents 16 powers 0, 1, and 2. Then, let's work with the largest number that is still smaller than the target number, in this case 16. Now we're going to multiply 16 by the highest number that fits our target number. In our case, 7 times 16 is equals to 112. This means that we know the first hexadecimal value. Subtract this multiplication by our target number. In our case, we would do 120 minus 112, having as a result the value 8. Now we're going to do these two steps again, in which we are going to find out which number multiplied by 1 returns us 8. In this case, it would be 8. Finally, we found out that 120 in the hexadecimal system is represented by 78. Now that we have all these concepts in mind, let's practice some exercises. So the first exercise that we can see in here is the following. We're going to convert the number 3A9, that it's a hexadecimal number, into a decimal. So how are we going to do this? We're going to first put the numbers 16 power of 0 until 16 power of 2, because here we have 3 characters, 3, 8, and 9. So we're going to have 16 power of 0 that it's 1, 16 power of 1 that it's 16, and 16 power of 2 that is 256. Then we're going to multiply these numbers with the respective number that we have in the hexadecimal. So what are we going to have? We're going to have 9 times 1 plus 10, because A represents 10 in hexadecimal, times 16. Then we're going to do 3 times 256, and the sum of this will be 937. Alright, so the respective number in decimal for 3A9 in hexadecimal is 937. Alright, now let's do the next exercise. So here in the next exercise is the other way around. We're going to have the number 230 in decimal, and we're going to convert this into hexadecimal. So again, what are we going to do? we're gonna create this this row in the table where we're gonna have the numbers 1, 16, and 256, because 256 is the highest number that it's right after 230. Then we're gonna get the highest number, 230, that it's 16 times 14, all right, that is 224, and we're gonna subtract. So 14 we represent with the letter E, so we know that the first hexadecimal value in our case will be E. 16, why? Because we're doing 16 power of 1, okay, so 16 times 14, it will give us 224, and if we subtract 230 minus 224, we're gonna have the number 6. Now we have to find out what is the second character for our hexadecimal number. So in this case, we know that 16 power of 0 is 1, and we have to think what number that times 1 will be equals to 6. In this case, it's the number 6 itself. So in the end, we know that 230 in decimal is the same thing as E6 in hexadecimal, okay? The third exercise that we're gonna do, we're gonna order the numbers from lowest to highest. And what are these numbers? In here, we're gonna start implementing the ideas that we already saw in the previous videos, all right? So we have here 11 in hexadecimal, 11 in decimal, and 11 in binary. So let's see, now we have to convert everything into one system, and in the system we can check which number is the highest and which number is the lowest. Okay, so to make our life easier, let's convert everything to decimal, because this is a system that we already know how to compare numbers. Okay, so let's convert 11 in hexadecimal to decimal. So what are we gonna do? We're going to put the powers of 16, so 16 power of 0 is 1 and 16 power of 1 is 16. Then we're gonna multiply 1 by 1 and 1 by 16. So we're gonna have 16 plus 1. And then we can sum this result, and we're gonna have 17. Okay, so 11 in hexadecimal is the same thing as 17 in decimal. Then 11 in decimal we don't need to convert, because it's already in the system that we're gonna compare the other numbers. And finally we have to convert 11 in binary to decimal. So again, remembering what we saw in the previous video, we're gonna do exactly the same thing as we're doing for hexadecimal, but instead of using the base 16, we're gonna use the base 2. So 2 power of 0 is 1, and 2 power of 1 is 2. So if we do 1 times 2 plus 1 times 1, we're gonna have the number 3. So in here, now we have the 3 values for these 3 numbers in different systems. All right, so we know that 11 in hexadecimal is 17. We know that 11 in decimal is 11. And 11 in binary, it's number 3. So we know that 11 in hexadecimal is the highest number, and the lowest number is the number 11 in binary. Okay, so now let's do the last exercise. That will be the other way around. The last exercise here, we're gonna do the same. We're gonna order the numbers from highest to lowest, so it's the opposite, but the idea is pretty much the same. We're gonna have the number AB in hexadecimal, then we're gonna have the number 109 in decimal, and the number 1010 in binary. So again, we're going to do the same idea of converting everything for the same system, and when we have this, we can decide, we can compare which one is the highest and the lowest. So let's start with AB. So AB, we're gonna start doing the first row, so 16 power of 0, that is 1, and 16 power of 1, that is 16. Then we have to convert A and B. So A has value 10 and B has value 11. And now we're gonna multiply and add rows. So 10 times 16 plus 11 times 1, we're gonna have 160 plus 11. And in the end, we're gonna have 171. Okay, so we know that AB in hexadecimal is 171. We know that 109 decimal is the same number for decimal, all right? Now we need to convert 1010 that it's in binary true decimal. And again, we're going to do the same thing. So here we have 4 digits, so we're gonna have 4 columns. So we're gonna start from right to left. 2 power of 0 it's 1, 2 power of 1 it's 2, 2 power of 2 is 4, and 2 power of 3 it's 8. Then we're gonna multiply the binary number with these powers. So we're gonna have 1 times 8 plus 0 times 4 plus 1 times 2 plus 0 times 1. And in the end, we're gonna have the number 10. So now that we have all these 3 numbers in the same system, we can classify which one is the highest and which one is the lowest. So we know that AB in hexadecimal is the highest number because it's 171. Then we know that 109 is the medium number because this is already in decimal. And the lowest number is 1010 in binary because it's only number 10. All right, so this is it for today. Next video, we're gonna work with the last system that we need to know. And in this video, we're gonna do a lot of exercises because it's going to be kind of the summary of this first session of the videos. All right, so I hope you enjoyed this content. If you enjoyed this, please give us a thumbs up, subscribe to our channel, and see you in the next video. Bye bye.